Okay, staying in this same section, 6-3, day 2, and we're just going to go backwards from what we did yesterday. Yesterday we did the derivative of the natural log function, and it was 1 over u times the u prime. Today we're going to be integrating a function of the form 1 over u. So I guess I'll put it right on here instead. So it's another integration rule. If we have the integral of a function that takes on the form 1 over u du, and remember we're asking what function has this derivative? Well, it's the natural log function. I am going to write this another way. Oh, and you also have to have, just like it's 1 over u prime, this is supposed to be the u prime. I'm just going to say times u prime here. So you need the derivative of the u attached to the du in order to integrate it. Another way you can see this is with a negative exponent. Remember, this is u to the first down here, and if I bring it up, it becomes u to the negative first power. So u to the negative first is the same as 1 over u. So if I run across either one of these, they follow the same rule because they're the same thing. Du with the u prime attached to it. If you have this form, it integrates to the natural log function. Now there's an absolute value, set of absolute value bars around the u because the domain for the natural log function, which we didn't look at, is always in the positive. So what's in here always has to be positive. And then our plus c. So today we're focused on looking for the form 1 over u du times u prime. If we get this form, we integrate it to the natural log of u. That kind of looks like a prime. Just forget that that's there. Erase that, I guess, would be your best bet so you don't confuse it with a prime. So it's 1 over u or u to the negative first. They're the same function. There's our rule. So we're just going to practice this rule today. So our first example, we've got the integral of 2 over x dx. Okay, I'm going to write that rule down up here. I'm looking to get 1 over u du times u prime. Then I can integrate that to the natural log of the absolute value of u plus c. Alright, so the 2, that's just a multiplier. I'm going to pull that out in front. And once we get going, you'll be able to skip some of these steps. So the 2, I'm going to pull out in front. And then that leaves me with a 1 over x dx. So now I fit the form perfectly. The derivative of x is 1. I don't have to change anything. So it's ready to integrate into the natural log of u, which in my u is an x. So the 2 carries along. Natural log, absolute value of the u part is the x plus c. So we're looking to fit this puzzle here. Integral of dx over 5x. Okay, we just haven't seen anything so compacted like this. I'm just going to slide stuff over. What I actually have in here, I can make this dx over 1, slide the dx over to the end. That'll leave a 1 in the top. And there's a 1/5 here. So I'm going to pull a 1/5 out in front. So there's my 1/5 that I pulled out in front. The dx is just going to slide over. And that leaves me with a 1 on the top, 1 over x dx. So now I'm ready to integrate. The derivative of x is a 1. So I'm good to go. So it's 1/5 natural log of absolute value of x plus c. Okay, another one. Integral of sine x over cosine x dx. Okay, well right away you might be thinking, oh, sine over cosine, that simplifies to tangent. But I don't have an integration rule for tangent yet. That's coming in another chapter, but not this one. So I have to do something else. And because we're doing the 1 over u thing, it looks like my u should be the cosine. So if I think about it, if I let u equal the cosine, the du is derivative of cosine is a negative sine x dx. So that tells me I need a negative sign attached to the dx in order for this to be a 1 over u situation. And I've got the sign here. I'm just going to slide it over. The other thing I have to do is multiply by a negative 1. If I multiply by a negative 1 here, to keep it balanced, I'm going to multiply by a negative 1 here. So now, keep the negative 1. That leaves me with 1 over cosine x with a negative sine x attached to the dx. So now I've got a perfect 1 over u prime times the du. So it's all good. So this goes away, and remember, anything attached to the dx, the u prime goes away with the dx. This is a 1 over u situation. So I've got my negative here, natural log, absolute value of cosine x. So my u is the whole cosine x in this problem. So it's your denominator that you're setting equal to the u. Number 4. I think I'll go up here. It might need a little bit more room. The integral of x plus 1 over x squared plus 2x dx. So again, we're probably going to let the u start with something. We're going to let u equal this denominator. So if I let u equal x squared plus 2x, my derivative is 2x plus 2. Well, if I look, that's really close to what I've got here. If I multiply this by 2, I'll have it. So to see it a little bit better, I'm going to factor the 2 out of these two baskets. That'll leave me with an x plus 1. Oh, I forgot my little dx here. Not that that's needed. So this is what I need attached to the dx in order for this to integrate to the natural log. So I'm going to slide this whole group over and multiply by that 2. So if I need a 2 here, I need a 1/2 out in front. And then I'm going to make it look right. So it's the 1/2 integral. I'm going to slide the x plus 1 over next to the 2. That'll leave a 1 in the top. X squared plus 2x. And then I've got the dx with the 2 times the x plus 1 all over here. So all of this gets thrown away. This is a 1 over u prime situation. So the 1/2 carries. 1 over u prime integrates to the natural log of the u. The u is the denominator. X squared plus 2x plus c. Oh, I forgot plus c down here. Okay, number 5. I don't think I can fit that in there. Chop that off. Let's see, we've got definite integral this time from 2 to 5 of natural log of x squared all over x dx. Okay, we're in that 1 over u situation. If I let u equal just the denominator here, x, the derivative of that is a 1. Well, I've got this natural log here. That doesn't help me at all. So this is not a 1 over u situation because this is still hanging in here. So if I look at this, well, maybe it's my power rule. Because if you look at our integration rules, we only have the power rule and now this 1 over u thing. So is this a u to a power, or maybe I add 1 here? Let's see. If I let u equal this, the natural log of x, the du equals derivative of natural log of x is 1 over x dx. Well, is there a 1 over x in this problem that I can slide over here? Well, there sure is. It's right here. Here's my 1 over x is right here. I'm going to slide that over. So I have the integral from 2 to 5 of natural log of x squared, and then I've got my dx with my 1 over x that I slid over here. So now it's just a regular old power rule. U to the second power. I have the u prime, so it's ready to go with power rule. Add 1 to the exponent. Multiply by its reciprocal. And then we evaluate from 2 to 5. You can pick up a calculator at this point. I guess I'll crank through it real quick. I'm going to use the y equals in the table because it's quicker. So I have, can you see, there we go, 1/3. And then it's natural log of x cubed. In the table, I want to start at 5. So at 5, I've got 1.3896 minus the value at 2, 0.44199, and then whatever that comes up. Okay, so this last one was kind of a trick one. They're not all going to be 1 over u today, so don't forget about your power rule. If 1 over u didn't work, then you got to try your power rule. All right, last one. Here, and it's different. We want to express the natural log of 2 using a definite integral. Okay, so what it's asking for is it wants natural log of 2 to be the answer of this definite integral problem. Well, if I want natural log in my answer, I know I've got to have a 1 over x. Okay, so let's think about it. The integral of 1 over x dx is the natural log of the absolute value of x with a plus c. Okay, what I want is the answer to be natural log of 2. So I need to figure out what numbers to put here, because I need a definite integral, so that I end up with natural log of 2. Well, because we didn't look at the function, one thing you don't know is that the natural log of 1 is 0. Or maybe we went over that in the first day, I don't remember. But the natural log of 1 is 0. So if I put a 1 down here, and a 2 up here, watch what happens when I integrate this thing. Plug the numbers in. So if I put the 2 in, I'll get natural log of 2 minus, and then I put a 1 in, natural log of 1. Well, the natural log of 1 goes to 0. Absolute value of 2 is 2. I get natural log of 2. So, if they ask you to express the natural log of some number using a definite integral, the equation is always the same, 1 over x. It's just your boundaries that are going to change. The bottom one's always going to be a boundary of 1, because that's what's going to give you your 0. And your top boundary is going to be whatever number you want the natural log of. So there that is. I think I forgot to write down the assignment. I guess I'm going to have to shut this off, even though it's supposed to only be one video today. I got to shut it off to see what the homework's supposed to be. So I'll be back in a second once I figure it out.